Hey, I'm going to quickly go over the homework for Power World. It's pretty simple compared to all of our other Power World simulations, but I'll just make this quick because there's a few things that can pretty easily go wrong. So here we have the problem description, and it mentions the Power World model from homework 3. If you do not already have that set up, just go back to the last video. All we're doing with this is relieving the overload condition with reactive compensation, and then also showing the flows. So those are the only two new things we're doing here, and they're both relatively simple. So I already have the circuit built here. You should have basically this exact same circuit after doing the solve power flow Newton. Yeah, so if any of this looks wrong, rebuild the circuit or check all the values and make sure they align. The first thing that we're going to do is show the actual flow of power. For this, we just right click. We're going to go to one line display options and then animated flows up at the top. We're going to show actual megawatt and mbar power flows. And then if you just do that, you're not going to see any changes. So you actually have to change this max line flow down here. Our max line flow is pretty low. As you can see on what the bus is outputting, it's 0.6 and 0.6. So I'm just going to put this as a value of 1. That seems to give us pretty good values. And then as you can see, once I do that, now it's scaling these arrows to be a proper size. If you notice the arrows are too small or too large, that's the value you change, and that'll correct that issue, especially for future simulations where we're going to have different generators and loads. So once we have that, we could see if you just do solve power flow Newton, it's nothing going to change. Or if we reset to flat start, it removes the arrows, and again, the arrows just stay here stagnant. But if we press this play up at the top, that's when we actually have the animation, and you can see what power you're inputting and then where it's actually going when it gets to your load. So moving on to the actual meat of this simulation, I'm gonna reset it and go back to edit mode. We're going to come back up here to draw, and we aren't going to add a series capacitor, which is what kind of everyone wants to do. We're going to actually do a switched shunt. I'm going to add this down here to the bottom. Now it's asking for the mbar values. I'm going to put 0 for now. Just so we can see it populate. Okay, that all looks good. The zoom windows are getting in my way. Okay, so here's the switch shunt. Right now it's set to 0 mbar. If I run this right now, as you can see, it isn't doing anything because it's set to 0. However, now that we have it in here, whoops. So once you have it here in here, it's set to 0. It's not doing anything. What we want to do is solve our power flow Newton, and on our generator end, it's gonna tell us the mvars that it's putting out. There, I'm sure, is a better way to do this with calculations. However, the lazy way, without having to calculate anything, is I'm gonna put more sig figs here. Is we're just gonna use this value that our generator is giving us, and we literally take that value, come over here to our switch, or what is it called? come over to our shunt. And we're just gonna put in the generator mVar values. So for us, that's 0.665484. And the more decimals you get, the better it's gonna turn out. There's nothing else that you have to change on this page for the way that we're doing things. A couple more sig figs. Perfect. So once we have this, when we go back up here, once we run and solve it, now we can see that our overloading conditions on our lines are resolved, and then our generator is outputting almost no mVars. They're all getting, we've relieved that condition with the shunt capacitor. And then when we press play, we can also now see the power flow, and we're getting like a tiny bit of, it looks like, reactive feedback actually to our generator. But everything is minimal. We've relieved the condition, and we have our simulation showing where all the power is flowing. That is basically all for this lab, or for this power world simulation. It's pretty straightforward.